When you open up the Word document, you'll see some tips on how to get onto the PhET Colorado Circuit Building website. Just for reference, even though this here shows a cell, you will have to add in a battery because there's no option for a cell in PhET Colorado. You'll make this circuit using an ammeter, and you'll have one bulb or filament lamp. You'll also have to include a voltmeter at the bottom. Now, the voltmeter on PhET Colorado isn't an inbuilt component, but there are pictures on the sheet to show you how to get there. You'll start at 0 volts on the power pack. To change the amount of voltage coming out of the battery, you double click onto the battery at the top, and then you'll be able to change the voltage. We start at 0 volts, which means on our ammeter we will get an initial reading of 0.0 amps and an initial reading on my voltmeter of 0 volts. Write those numbers down and then repeat them for all the rest of the values. When you've done that, there will be 3 questions. Describe how increasing voltage affects current. Describe how increasing voltage affects the brightness of the bulb. And then an extension question. Explain why the bulb changes the way it does. These will be on a Microsoft form for you. You will not have to draw a graph at this moment. We'll do those when we come back into school. Some information that we need to know for the rest of this lesson. An electric current is the flow of electrical charge, usually electrons, around a circuit. You can see here that we have a circuit with a battery, positive, negative, and electrons flow from negative to positive. However, the actual flow of electricity goes from positive to negative. The size of electric current is the rate of flow of electrical current. So we don't really talk about current being big or small. We just say that the rate gets bigger or the rate gets smaller. In a series circuit, the current is the same at any point of the loop, which means the rate of flow here will be the exact same over here. Here we have a copper wire. We have the electrons flowing through the copper wire. There's some key terms that are going to be coming up now that you'll be getting a task on. Potential difference, or voltage, is the energy transferred for every bit of charge that passes. And remember that charge is measured in coulombs. It's a packet of electrons. So when we talk about voltage, we're just talking about the amount of joules for every bit of charge that passes. That means we can define the volt as a joule per coulomb. This is something you have to memorize. The volt is the amount of energy that's carried by electrons. Voltage is also the amount of push given to the electrons. When we look at a simple circuit, when we look at a simple circuit, if I increase the voltage, so if I have a high voltage coming from my battery, there'll be more push given to the electrons, which means the rate of flow of current will usually be bigger. We measure voltage using a voltmeter. Quite easy to remember that because voltmeter literally means volt measure. We call electric current when there is any kind of flow of charged particles, and in electricity we call these electrons. There is an electric current. You can see the electric current in the wire up at the top. We measure current in amps. Ammeters are wired in series and measure current. All that means is if I was to draw a very simple circuit with a bulb, of course there'd be no gaps in the real thing. My ammeter will always be in line with the wires. It will never be in a separate loop. Moving charged particles, we call these electrons, form an electric current. Charge is measured in coulombs. The symbol for that is big C. We wanted to say what a coulomb was. We'd say that it's the amount of charge that passes a point in a circuit when there is a current of 1 amp for 1 second. So if the rate of flow of these electrons up here is 1 amp, and I time that for 1 second, then there would be a coulomb of charge passing. Now you don't need to remember this, but it's just an explanation of why that is. Each electron has a charge of that many coulombs, so a very tiny amount of charge. Electrons have got tiny amounts of charge. But if there's one current of 1 amp, if there's a current of 1 amp for 1 second, then billions of electrons will pass a particular point in the wire. Now this number and that number are inverse, so that means that I have got enough electrons passing that point in the wire to make 1 coulomb. You don't need to remember this, it's just an explanation, but you do need to remember this. 1 coulomb is a charge that passes a point in a circuit when there is a current of 1 amp for 1 second. The amount of electrons, the packet of electrons, we call a coulomb. Now this is the icon that I use for a coulomb because it's a packet of negatively charged particles, so they're electrons. Now, this task is given to you in your form. Please answer that.